All right, boys and girls, welcome back to another edition of Crush Lusher Television. All right, so here is the solution for homework number 95. Do it again. I asked you to do it by yourself first, so let's see what we got. All right, so we got F, we got G, and we got A as a constant. All right, first thing, find the value as x approaches -2 of f of x. Cool. All right, so here's my notes right here. So I wrote down my f of x and g of x function right there. So I want the limit as x approaches -2 of f of x. All right, no problem. So all I'm going to do is I'm going to plug in here. So the limit as x approaches -2 of this is going to be 3 times -2 squared minus 18 times -2 plus 24 over 5 times -2 squared minus 20. Okay, so what do we have here? So this is going to be 4 times 3, which is 12. -18 and -2 multiplied together is 36, positive plus 24 over 4 times 5, which is 20, minus 20 was 0. Uh-oh. So you get this right here. So 12 plus 36 is 48. 48 plus 24 is going to be 2. Then 4 plus 72. So we get 72 over 0. 72 over 0 is undefined, so the answer is undefined. And so we have a vertical asymptote slash infinite discontinuity at x equals -2. Cool. All right, there you go. Part B, we will find the limit as x approaches 2 of f of x. So I'm plug the same thing into 2. So it's going to be 3 times 2 squared minus 18 times 2 plus 24 over 5 times 2 squared minus 20. Cool. Remember, if you didn't get anything right, you're going to pause the video. You're going to make sure you got the corrections in, make sure you got it perfect, okay? And then reflect upon it, how you can do better next time, because this might be the last time we review it before we take that AP, all right? So make sure you speak up, make sure you monitor yourself, make sure you know what's going on, all right? Always feel free to text me with any questions or email me. Texting is probably better. So what do I got in my numerator? So I got 4 times 3, which is 12, minus 36 plus 24 over 20 minus 20. This is 12, this is 0, right? This is -24 plus 24, which is 0 over 0. Uh-oh, that is a hole. There's a hole in the graph. So I also have to get the answer there. So one thing I know, that there is a hole or removable I'm going to spell removable right. Sorry, my bad. Let's spell that again. Removable discontinuity at x equals 2. So at x equals 2, something's going on. But what is that limit? As we approach from the left and the right, there's a hole there, but what is the y value? That's what I'm trying to figure out. Okay, so I got 2 courses of action. What do you think I'm going to do? Yeah, I can factor, or I can use L'Hopital's rule. Let's just use L'Hopital's rule because that might be simpler. So I find the derivative of the numerator and derivative of the denominator. So that's going to be 3 times 2, which is 6x minus 18. And my derivative of the denominator is going to be 10x. Now I'm plugging 2 again. 6 times 2 minus 18 over 10 times 2. So that's going to be 12 minus 18, which is -6 over 20. Divide by 2, cut those in half, -3 over 10. There we go. So that is the answer for part B. So I have a removal discontinuity, a hole at x equals 2, and where they approach from the left and the right is approaching -3 over 10 on the y. Cool. All right, part C, horizontal asymptotes. So that's the limit as x approaches infinity. But in this case, there's also 2 things going on. So if I look here, so the limit as x approaches -1 from the left goes here. So that's from the left. So as I approach from the negative infinity from this direction, there's this function. And then as I approach infinity positive, I go to this direction, so I'm on this function. So there could be a different horizontal asymptote on each of these sections. So I gotta actually figure out both. So I want the limit as x approaches infinity, and then the limit as x approaches negative infinity also of g of x, that function. Okay, so infinity is greater than 1, obviously, so that's f of x. So I'm looking here, if I plug in infinity, that means that x squared and x squared is the biggest power, so that is 3/5. So that's 3/5, and so y equals 3/5 is one of the horizontal asymptotes. At limit as x approaches negative infinity, okay, so if I plug that in here, negative infinity, all these is going to be so small compared to this big power and this big power, but this power on the numerator is going to be so much bigger, and so the answer is going to be infinity right there. And so there's no horizontal asymptote when you have infinity as your limit. So that's it. Make sure you have this work too, because you need to have both. All right, part D. Okay, so you got to find it's the fact that they are continuous. Okay, at x equals 1. So what would a equal when x equals 1? That's the last part. Well, in order to do that, the limit as x approaches 1 from the left of g of x has to equal the limit as x approaches 1 from the right of g of x. So like the limit from both directions has to approach the same y value, or else if you have approaching a different y value, you have a jump discontinuity there. And so to make sure, the first thing, we're approaching the same y value from the left and the right, we got to plug in 1 from the left, which is this part, on x, and then 1 from the right, which is f of x, which is this part here. So this and this have to be the same when I plug in 1. And so if I plug in 1 for x, I can get a, because that would be the only variable left. Okay, so let's do that. So 3 times 1 squared, I'm plugging in 1 here, minus 18 times 1 plus 24 over 5 times 1 squared minus 20 has to equal 4 times 1 to the 5th, and now I'm plugging in 1 here, minus 5 times 1 to the 3rd plus 3 over 7 times 1 to the 3rd minus 5 times 1 squared plus 1 plus a. And so this is what I need to solve right here. And when I multiply by 1, that's essentially just getting rid of all the variables, right? So this is 3 minus 18, which is negative 15. Negative 15 plus 24 is negative 9. So negative 9 is my numerator, and this is 5 minus 20, which is negative 15 on the denominator. This is going to be 4 minus 5, which is negative 1, plus 3, which is 2. 7 minus 5, which is 2, plus 1, which is 3, plus a right there. So now I can get a because that's the only thing I know. So I'm going to subtract 2/3 right there. So this simplified is positive positive divided by 3, and you have 3/5 equals 2/3 plus a. Subtract 2/3. So common denominator is 15. So 3/5 times 3 over 3 minus 2/3 times 5 over 5. So that's going to be 9 over 15 minus 10 out of 15, which is negative 1/15. There we go. So a would be negative 1/15. So that's a equals, in order for the limits on the left and the right to be equal to each other, and then you're on your way after that. Prove the continuity, but you don't have to do that. All you have to do is figure out what a equals. Cool. Nice job. Hopefully you got them all right. If not, fix it and then reflect upon it. Good work, everybody. Take care.